Hello, welcome to Plutus Project-Based Learning 2023. My name is Frédéric Samvoura, and today we'll be going over Module 301, which is writing and using Plutus validators, in particular in the Module 301.1, which is about writing Plutus spending validators. And the script is a validator because it validates whether the user, the transaction, is allowed to spend the output. So basically that's the validation it does, and that's why it's called the validator, and it validates whether the spending is allowed at the script. There are different types of validators. There are validators according to their purposes that handle the control of the logic behind minting native tokens. Other control the logic behind distributing the staking rewards, and the ones we will be covering, we are the ones that control the logic of spending funds held at a smart contract. And by the time you finish this course, you should be able to fund, meaning send fund at a smart contract, and spend, meaning unlock funds held by the smart contract. We need tools and resources in order to accomplish this, and the prerequisite for you is to know how to submit transaction via the command line, which is using the Cardano CLI, and you also need to have a running node. In this case, I do have my pre-prod node running, and it has already been synced. I can see that it is still synced and it's 100% synchronized. I can send transactions on the blockchain. And you also need templates. We'll be using templates of the Always Succeed validator, and by using templates we make ourselves an easy job, as we do not have to write our own, construct our own dependencies. The spending validator has three main elements, which are the datum, the redeemer, and the context. The parameterized validators have their own parameters, but for the sake of the main elements are the datum, the redeemer, and the context. The datum is a piece of data which is attached at the output itself. It could be inline, visible, and that is since the Vasil hard fork, which allowed for inline datum. And it can also be hashed, meaning encoded. The redeemer is also an arbitrary type of data which is sent during the validation process, and it involves basically interacting with the smart contract, whereas the datum can be used to carry the state of the transaction of the smart contract. The context is an information surrounding the transaction, for example, how much you are spending, who is signing the transaction, what time it is. So that type of information, the user need not send it specifically, but while validating the transaction, the validator will have elements that constitute the context of the transaction. The Always Succeed contract in this case does not do any validation. It always succeeds. However, there is one basic validation it does, especially if the datum is in the form of a hashed value, meaning encoded value. The datum you sent need to match the value expected. And if there is an inline datum, then yes, there is no validation. You can basically tell the smart contract that the inline datum is present, and itself will handle the validation of the datum. The Always Succeed has this format: the datum, redeemer, and context, and it returns an arbitrary value, in this case a null value. For the Always Succeed, we expect it to be a true value, a success, and if it's a failure, then it has to be an error. So in this case, the first part here will always allow you to spend, whereas this part here, even though they both do not check the value of the three parameters, which are basically the datum, the redeemer, and the context, represented by these underscores, This one, the always fail will return an error, whereas the other one will return a null, which will validate. And then after you've created your functions, in this case, the always succeed, you can create a validator function which you can use in the compilation process, which we'll see shortly. And in this case, we have a Plutus smart contract, which is of the type .plutus, which is going to be created. And from it, we can derive an address. We can call it always succeed May 19 address, as we are on May 19 today. And once we have this address, we can see what is the value of that address, and we can now start sending fund at that smart contract address. In order to lock and retrieve funds, there are three main steps: is to construct your transaction, to build the transaction using the error, the Babbage error, the network on it where you are, your change address, and input for paying the fees or sending the funds at the smart contract, the output at the smart contract with the value you're sending. An inline datum in this case will be sending a file for the inline datum, and will output a temporary file which will be signing. So using this file, you sign and then you submit the transaction with the signed file. So now we know how to create a always succeed smart contract. Let's do it in practice. And once we have done that, we could be able now to create smart contracts with other type of purposes, which will be coming in future lessons. So in order to see our always succeed validator, we are going to look at this file, which is the always succeed validator. Before writing the name of your module, you import dependencies depending on which functions or types you use, and also some modules from Plutus library, and you can basically import them according to your needs. In this case, we need the built-in because we're using the built-in data, and this built-in data, the arbitrary data type that will be used to create the datum and the redeemer, and we'll have our context. However, these three elements will not be verified. That's why I have underscore here. However, regardless of their values, we'll have a true, which means a success. Okay, so this is the always succeed validator. And once you create your validator, you can call it into your compiling function, and it's going to basically compile. In this case, I'm calling this function for the compilation the validator itself, because it's going to be used in the compiling to create the Plutus script. Let's look at the compilation script. Again, you import some dependencies and module for the validations. Okay, from the Plutus library and some other libraries. I zoomed in so that you can see. You import the always succeed validator, which is the one we had created earlier, and then from it you have its own function. Basically, you have the always validator module with its validator function, which is called to create the Plutus file using the always succeed script function. Okay, so that's what we have. Now we can try and use the Nick shell to go and compile this script. In order to use the Nick shell, you need to go into the Plutus apps of the Cardano library and check out the corresponding tag. In this case, I'm going to check out this one, the v1.0.0 alpha 1. That's what I need to check out to get this particular version of the Plutus apps, which is used in my Cabal project. Okay, so git status, it's already checked out, but if I had not checked it out, I would have done git checkout v1 and so on, this file basically. Okay, but in this case I already have it, so I can go into init shell, and init shell should not take long to be available as I had already run it. Okay, so while the init shell is loading, I'll be looking into the output folder where I expect to make appear and always succeed May 19 Plutus. As you can see, it's not in the list of files, but I expect it to show up somewhere here. Okay, so once we're in the init shell, we go back to the location of our Haskell files. This is PP PBL Plutus. Okay, so now we can go into about repo, and we'll have the always succeed compiler ready, from which we run the compiling function, which will create the Plutus script. And we expect it's a write, meaning success. And as you can see, the always succeed May 19 Plutus has been created. And now from it, we can create a May 19 address from this Plutus script. I have some comments ready for today, so I can save it. And before we start, I can basically have first my shortcut for the testnet, which is preprod, and then from here I can go and paste the values. I need to create an address, the May 19 address, the always succeed address. So in this case, I need this command. Okay, so I already created the testnet, so here I can just use the shortcut. Okay, so perfect, so that should work. Before I do, I can just show you that I do not have the May 19 address. Okay, but when I do send this command and I do the list of files, you can see the May 19 address has already been created. Okay, that's the one we'll be using. The script we'll be using will be, I'm creating again shortcut file variables for these files. So I'm going to use the May 19 Plutus as a script used. The smart contract script will be the May 19 address, resulting into the May 19 address, and that will be the smart contract address. I'm going to send 50 ADA, test ADA, the smart contract address, and I'm going to use the address one as my paying address. Okay, so these four files, these four variables, I'm going to create them. Shortcut variables, environment variables for me to reference them. Now I need some test ADA to pass the transaction in order to send the 50. So I need to query my address one's UTXOs so that I can basically use them. So Cardano CLI, query UTXO, get an address given by address one on the preprod testnet. Okay, so address one, I have it. Query UTXO. Okay, so testnet magic. I did not send testnet magic 1. Okay, let me see. Copy. Perfect. Testnet. Cardano query. Testnet. Okay, perfect. Forgotten those two. Yes, so we are now at the UTXO of the first address, and I need something around 50 it tested that this is too small. This should be enough. Okay, so index 1. Okay, so I'm going to use this one as the UTXO used to spend, and now we can log this UTXO in its own variable that I may use later. And now we can send the transaction. So I'll be using this UTXO as the input. The output will consist of the address and the output value, which is in this case 50 ADA. And I'm going to use the inline datum in the type of a datum JSON file. Let me show you how it looks like. Datum JSON. In this case, the datum JSON is basically an arbitrary type of data with a constructor, 2 fields, both are integers, 35 and 53. Okay, that's our datum. And we create a transitory file called May19 draft. You can call it anything you want, but you'll go through the same process of creating it, signing it, and submitting it. Okay, so let's now create the file to the transaction file to sign later. The fees are estimated once you create the transaction. Now you can sign it using your signing key. In this case, I'm using address 1 signing key, and now I can submit the transaction. So this transaction has been successful. Again, if we echo smart contract address, and we go on the Cardano CLI, on the Cardano pre-prod scan, Cardano scan, and I put in the address. It has 50 ADA. Okay, it just got 50 ADA, but it has 13 transactions. A few are mine on April 19. However, before myself, that's me maybe on April 19. But 6 months ago, some other people had already used this smart contract. And you may ask yourself, why is it so? Is because once you create a knowledge succeed, again, you are creating a logic which can be recreated by other people who may use this same smart contract address independently from you, given that the logic is the same. So you can create the same smart contract, and people may actually create the same address by creating the smart contract, and you'll both actually have created the same smart contract unknowingly. Okay, if the logic is similar. So we have sent the datum with an inline. We are going to now send, and on Cardano scan, you can see it appears with 50 ADA as a balance. Let's see how it appears on the Cardano CLI. Because I need to change this address into smart contract address. Okay, so there is a 50 ADA with the inline datum. As I said, it's basically readable. You can read it, and from it, it's basically trivial to very easy to reproduce the datum we had seen earlier, which is the constructor 0 with an integer 35 and another integer 53. Okay, however, we may need this value once we want to spend it. Now I want to send another UTXO of the same value, but with a hashed value. Okay, in order to hash the value, you basically need to hash the datum file. I had already hashed it, and the value is this is the hashed value equivalent to this same datum. Okay, it's the same hash value, and that is the one I'm going to send here. Okay, So I now need a new UTXO in order to send pay the fee and send the 50 ADA again. So I'm going to query again my balance at my address number 1, because the UTXO I had used earlier had been consumed, so it's no longer available. So I can reuse this one, index 1, as an input value. Perfect. This is the one I'm going to use for the second transaction. And now I'm going to do the same. However, instead of sending a TX out inline datum, I'm going to send a TX out datum hash, okay? And the process will be similar. And I'm sending the hash in this case, not the value, not the file. Okay, so you say you create the transaction. It's tricky to find the last digit. Okay, so yeah, I got it. Now I can basically create the signed version of the transaction, and I can now submit. I'm copy pasting. So the transaction has been successfully submitted, and now we can go back and query the value at the UTXO. It now has a value of 50, both are equal values. And here, if I refresh, it's still showing 50, but it's going to show 14 transactions and 100 ADA. Okay, so Cardano scan may wait for a certain number of validations, confirmations, whereas in the CLI, I can already see the transactions. Okay, so now what will happen is we're going to try and spend these two UTXOs. We'll start with the one which is hashed, because it's the one which we may happen not to know the value. The one on top, it's very known by anybody, even you, where you are watching this, you can basically go and spend it, because you know it's a datum of constructor 0, integer 31, 35, and integer 53. Okay, however, when you look into this hash, you may not know the value, even though now you know it's actually the same as the one above. Okay, so let's try and spend it. What we'll do, we'll have to get the UTXO we want to spend, this one with index 0. So I'm going to try and retrieve the 50 ADA in this case. First of all, we need to obtain the current parameters of the blockchain. Okay, it's important when you want to interact with the smart contract, especially when you want to spend it. You need to have your protocol parameters updated. Sometimes there are changes happening on the blockchain, and you may have a failed transaction because your protocols, the parameters guiding the blockchain, are not updated on your side. Okay, so now we have a new protocol.json, and we'll be using it to spend. So I need to go back and get again my text here, okay, which is index 1, index 0. I'll call it the transaction to consume, which is index 0. I need the collateral. For, in this case, I'm going to use address 2 as a spender, consumer of the UTXO. So once I do that, I have to check the UTXO that address to find one I can use to pay for the fees, and if I was to send funds, but in case I'm going to pay fees and get funds instead, so I need a small amount. This one will do. Okay, this one I know I have used it as a collateral, so I will keep it as a collateral. It won't be spent, so I need this one with index 0. So it's going to be the spending one. I know the collateral is correct because I've not spent it. It ends with a D2C. This is the D2C. This is the one here. Okay, so the collateral. So I'm going to send these three variables again as shortcuts. Okay, abbreviations of those UTXOs. I'm going to use the no, I'm not going to use the datum JSON. I created another one which is called false. Let me show you how it looks like. Sorry about that. This one here, sorry, it's called false. So you know that in the datum we have 3553. In the false one we have 4553. Okay, so we'll have to change that. So let's use the false one, which is false. Okay, is it underscore false? Yes, it's the datum underscore false dot JSON. Okay, that's what we'll be using. Now we have the same transaction. Yes, we have the F1, which is a spending one, as an input, the collateral, which is collateral 1, and now the this one is the consumption, the one we're consuming from the UTXO, from the smart contract. We're using the Plutus script in use, which is the one we had used earlier, the May 19 Plutus, correct. There is a txin datum file, which is the one we want to use to pay. The redeemer is redeemer.json. I had not showed you how the redeemer looks like. It's a null value basically. There is no field in this data type, so it's an empty field basically. It's a null. It's an empty, no field in this one. So that's the redeemer we'll be using. Again, it won't be validated, right? So we just need to send it. And the change address is address 2. The protocol parameters are the ones I just created. I create a temporary file for the signing. Okay. However, I do expect an error here because I'm using the false data. Cool. So yes, there is an error, and we are basically told that the Plutus script witness has the wrong datum according to the UTXO. So the expected value has hash of this value, which is indeed what is here. Okay, we know this is the value, but the one we sent doesn't have that value. We could have hashed what we sent and see whether it works, but we know it won't work, right? So now let's get the correct one and we'll do the same. It's basically, it should validate because we have now an estimate of the fees. Same process once we have created a transaction file. Again, I'm copying here with shortcut of the keyboard, not on the mouse, just to be quick. We are submitting this, we are signing it. Now let's submit it. Again, copy, which I can use with the key also. The transaction has been successfully submitted. Again, remember we're consuming this one here. So once we query the UTXO at the smart contract, we should see that the one with the datum hash has been consumed. Not yet. We can wait a few seconds. Let's see at the node level if anything is in the memory. Yeah, there's some memory here. The mempool is not yet purged. Let's wait for a new tip to extend, and that's why we know that the transaction will have gone through, at least on our end. Okay. so you can watch it as it goes. It takes a little while to go through. Okay, so we basically still have a new tip at extended, and then the transaction should have gone through now. Perfect. So we have spent the 50 ADA from the smart contract with the hashed value. Now we have the one remaining with the inline datum. The inline datum is basically a trivia exercise. And this point is you don't even need to provide any datum. You just need to know your datum, your spending you take. So in this case, I'm going to write this one. The collateral is still the same. I need a new UTXO for the fees. Okay, so I need to go and check the value at my address number 2. Okay, I can now use this one here, index 0. The collateral has not been spent, so I know that this one is still correct. And if you check, you can see that it is still available here. This is still the collateral with index 1. This is the same value. Okay, so it's still available. I can send these 3 values, a command line for shortcut variables again, not having to type all of these, even though I can still type them if I want. So I'm going to retrieve now the inline datum, which is we will build a transaction, the Babbage error, testnet, an input for the fees, a collateral, an input which is being consumed at the smart contract. We are using the same Plutus script. However, you can see now we are telling the script, the validator, that the inline datum is present, and we have a txin redeemer file, a JSON, which is the same. We have a change address, protocol parameters arrays, and again another transaction file to create. Okay, copy. The fees are estimated, and depending on whether you are using a Plutus script here, for example, here we're saying that we are using a Plutus script. If you are using a Plutus reference, then it's going to be a reference script, and both your command will be different in terms of referencing the script, but also you'll have a different command from the inline datum as well as the redeemer. So according to the type of script you're using, whether referenced or the script itself, you'll have different commands for these 3 values. Okay, so pay attention to that. But today we are covering the process of spending the Plutus script by sending it to the in the validation, and not referencing another UTXO holding a reference to the Plutus script, which we'll see in future lessons. Okay, so we have now a temporary file that we need to sign with the signing key of player 2. The player 2 has signed. Same process, always build transaction, sign transaction, submit transaction. Okay, perfect. So now everything has been submitted successfully. Quickly, before it validates, I can go and check whether it's still there or not. It's still there. We'll check the mempool again. It is still in the pool of okie dokie, so it has been submitted. Now it should have gone through. Good. So now we have an empty smart contract. We did send and consume funds of different types in the inline format and in the datum hashed format. And should you have any question, please join us at Gimbal Labs Live Coding, and we'll be going over this again together. Thank you, and see you at lesson 301.2. Bye.